Here's something that rarely gets mentioned in AI demos and tutorials. Every AI agent you interact with forgets everything the moment your session ends. It doesn't matter how capable the model is. Without an external memory architecture, it's essentially starting with amnesia every single time. This isn't a minor inconvenience. For any agent doing serious work across weeks or months, it's a fundamental limitation that breaks real-world usefulness. The quick fix most developers reach for is pasting documents directly into the system prompt. And for small, contained tasks, it works reasonably well. But the moment your project spans months of notes, hundreds of decisions, and dozens of evolving documents, that approach collapses. Context windows have hard limits, and more importantly, raw text stuffing gives the agent no structured way to reason across that information. You're essentially handing someone a pile of papers and asking them to instantly know everything inside. Traditional retrieval augmented generation works by converting your documents into vector embeddings and finding the chunks most similar to your query. It's genuinely powerful for lookup-style questions. What did I write about topic X? And it's fast and relatively cheap to implement. But it fundamentally cannot synthesize meaning across time. If the answer to your question only becomes visible by connecting threads from documents written 3 months apart, vector similarity will return relevant fragments without ever surfacing the actual insight hiding between them. Microsoft GraphRAG takes a fundamentally different approach. Instead of waiting for your question to go find relevant content, it reads all your documents at index time and constructs a knowledge graph, mapping entities, relationships, and thematic community clusters across your entire corpus. By the time you actually ask a question, the cross-document reasoning is already embedded in the structure. You're not searching text for similarity. You're traversing a pre-built map of meaning. Think of it as the difference between searching a library and asking someone who has already read and connected every book inside it. The implementation is more approachable than the underlying complexity suggests. You point GraphRAG at a folder of documents, session logs, project notes, decisions, whatever you want the agent to remember, and run the indexer using a cheaper model for entity extraction to keep costs manageable. A stronger model handles actual query reasoning. From there, you spin up a local REST endpoint so your agent can call GraphRAG before defaulting to, I don't know. Adding a scheduled incremental reindex in the early morning hours keeps the memory current without requiring a full, expensive rebuild every day. The real validation came from asking a synthesis question about a project with a months-long history. No conversational context provided, just the raw document archive. GraphRAG connected threads from files written months apart, surfaced implicit dependencies, and reconstructed decision logic that was only visible by reading across the entire corpus simultaneously. A vector search would have returned the most relevant individual chunks, which is genuinely useful. Graph traversal returned the actual answer that emerges from the space between those chunks. That's a qualitatively different capability. Intellectual honesty demands acknowledging where GraphRAG falls short. It has no native temporal reasoning. If an older document contradicts a newer one, the graph surfaces both equally, and you still need logic to determine which is current. Query latency runs around 20 seconds, which is perfectly acceptable for a background agent call, but completely unusable for real-time conversational interfaces. Initial indexing of a large document corpus takes meaningful time and compute budget. These aren't deal breakers, but they are constraints that should shape how and where you deploy this architecture, rather than surprises you hit in production. For AI agents that need to operate meaningfully across long time horizons, tracking evolving projects, learning from accumulated decisions, reasoning over months of context, GraphRAG represents the most practical architecture currently available to developers building outside of enterprise budgets. It isn't a perfect solution. No single approach to agent memory is. But it moves the needle from agents that are stateless tools to agents that actually accumulate working knowledge. The gap between impressive demo and genuinely useful over time often comes down to exactly this layer of persistent, structured memory.